Imagine your company just deployed a brand new, state-of-the-art AI assistant. A customer logs into their portal, they ask a really complex question about their financial account, and the AI confidently just fires back an answer.
And the language is perfect?
Or completely. The tone is perfectly professional.
Yeah.
But there is just one massive problem. The information is entirely fabricated. And under the new EUAI Act, the provider of that AI model is not the one liable for that hallucination. You are.
Yeah, the deployer.
Exactly. You, the deployer. And the penalty for letting an automated system mislead a consumer in a high-risk sector, it could be up to 6% of your company's global revenue, which, let's be honest, that is not a slap on the wrist.
No, for a lot of enterprises, that is a company-ending event.
Exactly.
And the liability landscape has just fundamentally transformed. Their responsibility has shifted squarely onto the shoulders of the business running the software. So if you are a European business leader, a CTO, or, say, an enterprise developer evaluating your infrastructure this year, this is the uncompromising reality that you were building in.
Which brings us to the core of our deep dive today. And I have to share this truly staggering statistic. So we are looking at the 2026 Enterprise Guide from AetherLink.
Right, the Dutch AI consulting firm out of Den Haag.
That's the one. They're the architects behind the Aetherbot, Aethermind, and AetherTV product lines.
Yeah.
Well, according to their research, 78% of enterprises planning AI deployments in 2026 have completely abandoned the idea of using a single standalone AI model.
Wow. 78%.
Yeah. They're just tossing the whole one-size-fits-all chat interface in the bin and going all in on multi-agent orchestration.
Well, I mean, we are really witnessing the end of the novelty phase. A single AI chatbot is great for, drafting an email or brainstorming, but it absolutely cannot safely run a business process.
Right.
We're moving into an era of real production-ready infrastructure. You have multiple specialized AI agents working together in these coordinated teams to execute complex enterprise workflows.
And doing all of that while navigating some of the strictest data regulations on the planet.
Exactly.
Okay, let's unpack this, because our mission today is to figure out how you can actually construct these powerful multi-agent systems without accidentally bankrupting your cloud computing budget.
Yeah.
And, most importantly, without failing an EUAI Act audit.
Right. Definitely want to avoid that.
So let's tackle the architecture shift first.
Yeah.
Why are 3 out of 4 enterprises deciding that having one massive, incredibly smart AI is just no longer the solution?
It really comes down to a fundamental clash between how monolithic AI models work and what complex enterprise operations actually require, because a monolithic model is a generalist.
Right? Knows a little about a lot.
Exactly. It's been trained on a massive swath of the internet to do a little bit of everything. It can write code, it can summarize text, translate languages.
Right.
But in a business setting, you rarely need a generalist. You need highly specialized functions with very strict guardrails.
Makes sense. It's kind of like hiring one person to be your company's lawyer, your marketer, and your lead accountant all at once.
Yeah.
It's just a terrible idea.
That is a perfect analogy. The 2026 Enterprise Guide actually highlights this. Trying to force one model to act as your data analyst, your compliance officer, and your customer service rep all at the same time, it leads to a massive degradation in performance across all 3 of those roles.
I see. So if I have a single neural network trying to process a customer's loan application, it has to juggle the math of the interest rates and the nuances of regional lending laws and the formatting of the final approval letter, all in one prompt.
Yes, all within the exact same prompt execution. It's spreading its processing power way too thin.
So it just drops the ball.
Precisely. And multi-agent orchestration solves this by distributing the cognitive load. You deploy what's called a hierarchical pattern.
Okay, hierarchical. How does that look?
Well, Gartner released some fascinating data on this late last year. They showed that enterprises using hierarchical agent structures reduce orchestration errors by an impressive 64%.
Wait, 64%? Just from splitting up the tasks?
This is from the architecture shift, yeah. In this setup, you might have a supervisor agent. Its only job is to receive a task, break it down into subtasks, and hand those off to specialized worker agents.
Got it.
So one worker exclusively retrieves documents, another exclusively runs math calculations, and the supervisor just aggregates their work at the end.
Okay, I have to push back on this from an engineering perspective, though.
Sure.
Because I've managed complex software systems before. And whenever you have multiple pieces of software talking to each other, passing data back and forth over APIs, debugging becomes infinitely harder.
Right. The complexity goes up.
Yeah. If I have 5 autonomous AI agents handing off micro-decisions to each other all day, doesn't that make a regulatory audit an absolute forensic nightmare? Like, if the final output is illegal, how do I even know which agent broke the law?
That is a really common concern.
Hmm.
But the reality of the technology is actually counterintuitive. Multi-agent systems actually simplify root cause analysis.
Really?
Well, especially when you compare it to monolithic models. Think about how a single large language model operates. It is a trillion parameter black box. If it gives a bad financial recommendation, the Y is distributed across billions of mathematical weights and biases.
Yeah, you can't exactly crack it open and point to the line of code where it decided to deny a loan.
Because there is no line of code. It's just a probabilistic guess based on its training data.
Right.
But when you break that workflow down into discrete, specialized agents, you are forcing those agents to communicate with each other. They have to pass text, code, or structured data back and forth.
Oh, I see.
Yeah, that communication creates a deterministic, highly visible paper trail. Under the EUAI Act enforcement mechanisms taking effect this year, high-risk systems require what are called Article 24 explainability artifacts. You essentially have to prove your work to an auditor.
Meaning I need to hand over a log that proves exactly how the system arrived at a decision.
Right. And with a multi-agent setup, your logs don't just say, the AI decided X. Your logs say, Agent A retrieved the 2025 lending policy. Agent B extracted the applicant's income from the CRM. Agent C compared the income to the policy and flagged a risk.
Wow, okay, so if the final decision is wrong, you simply look at the handoff logs. You can see instantly if Agent A pulled an outdated policy or if Agent B just hallucinated the income.
Exactly. It gives you the modularity to isolate the failure, and that is critical for the mandatory incident reporting logs and the quarterly bias audits required by Den Haag.
That makes total sense.
Yeah.
You're turning a massive opaque brain into an assembly line where every station basically scamps its ID on the part before passing it down.
Yes, that's exactly it.
But, that assembly line metaphor brings up a critical flaw.
Okay.
Even if I can track exactly which agent on the line made a mistake, how do I stop them from making things up in the first place? I mean, if Agent A hallucinated the lending policy, the fact that I have a pristine log of the hallucination doesn't save me from the 6% revenue fine.
No, it absolutely does not. The documented hallucination is still a hallucination. And this is the pivot point where the architecture has to evolve from relying on what an AI, quote-unquote, knows to what an AI can actually read.
Right.
The AetherLink guide spends a huge amount of time on the cure for these fabrications. It's an architecture called RAG, or Retrieval Augmented Generation.
Okay, so for the business leaders listening who might not be deep into back-end data engineering, let's break down the mechanics of RAG. Traditionally, when you ask an AI a question, it relies on its parametric knowledge, right? Like the information baked into its neural network during its initial training phase.
Yes.
But that training is basically a snapshot in time. It might be a year old. It definitely doesn't know that the European Central Bank updated a critical compliance rule yesterday.
And asking an AI to rely on outdated parametric knowledge for a sensitive business operation, I mean, that is professional negligence. RAG completely bypasses that memory.
So it doesn't just guess.
No. Instead of asking the AI to guess the answer, RAG forces the agent to take the user's question, translate it into a search query, and look up the answer in a secure, mathematically sorted library of your company's actual documents.
And this is typically done using a vector database, right? Let's hover on vector databases for a second because that term gets thrown around in boardrooms a lot. How does that actually work under the hood?
So a vector database takes your company's raw data, PDFs, policy manuals, HR guidelines, and it chops them up into small paragraphs or chunks.
Okay.
It then assigns a complex mathematical coordinate, a vector, to each chunk based on its contextual meaning. When a user asks a question, the system assigns a coordinate to the question itself.
Oh, I see where this is going.
Right. The database then simply looks for the chunks of text that are mathematically closest to the question. It retrieves those specific paragraphs and hands them to the AI agent, essentially saying, do not use your training data. Read these exact 3 paragraphs and synthesize an answer.
So you are stripping the AI of its role as a knowledge base and basically demoting it to a highly capable reading comprehension engine.
That is the perfect way to conceptualize it, demoting it to a reading engine. And the AetherLink guide notes that RG-enhanced agents reduce factual errors by a staggering 72%.
72%? That's massive.
It is, because you change the AI's internal dialogue from, I think I remember, to I am citing page 4. of our internal policy. And to see how this transforms in operation, AetherTV actually provided a fantastic case study in the guide involving a mid-sized financial services firm based in Den Haag.
Oh, I read through this one. This firm manages roughly 800 million euros in assets, and they were just drowning.
Completely drowning.
Yeah, they were receiving hundreds of regulatory inquiries, and under their legacy manual system, a human compliance officer was spending, 8 to 12 hours hunting down data to respond to a single inquiry.
Exactly. And regulations often demand a 48-hour turnaround, so they were perpetually operating on the razor's edge of non-compliance.
So AetherTV stepped in and replaced that manual scramble with a 3-agent architecture.
Yeah.
And they didn't just throw a chatbot at the problem, right? They built a really highly structured workflow.
They did. So Agent 1 is the regulatory interpreter. When an inquiry comes in from a regulator, Agent 1 uses our RAG to query a live, constantly updated vector database of Dutch financial regulations. Its only job is to translate the regulator's question into internal data requirements.
Right. It figures out what the regulator's actually asking for.
Yes. Then Agent 1 passes a structured checklist to Agent 2, the data discoverer. Now, Agent 2 has secure access to the firm's internal customer relationship management systems and their transaction databases.
Okay.
It hunts down the specific client data requested, and it attaches clear data lineage tags to everything it finds. Finally, both the regulatory translation and the raw client data are handed to Agent 3.
Response composer.
Exactly. Agent 3 synthesizes everything, drafts the formal legal response, and explicitly flags any discrepancies or missing data for a human compliance officer to review.
That is a brilliant separation of duties. And the performance metrics, after 3 months of deployment, they're hard to argue with. The firm's average response time plummeted from 40 human hours down to 12 automated hours.
Which is incredible.
And their accuracy hit 99.2% because the complex synthesis was handled by the AI, while the final human-in-the-loop review caught the edge cases.
Oh.
And they dropped their cost per inquiry from 820 euros to 145 euros.
Yeah. And here is the metric that matters most to an auditor. They had 0 follow-up questions from regulators on 87% of their submissions.
Wow.
0.
Because of that multi-agent handoff we discussed earlier, every single response generated by Agent 3 automatically included a detailed decision chain, showing the regulator exactly which internal data and which external rules inform the answer.
That transparency is incredible, but, it raises a technical question for me.
Sure. We hear constantly about fine-tuning, the process of taking an open source model and spending hundreds of thousands of dollars training it further on your proprietary data. If RAG is this effective and it cuts errors by 72%, why does anyone bother fine-tuning anymore? Is that just a dead practice now?
That is a really common point of confusion. If we connect this to the bigger picture, fine-tuning and RAG are not competing solutions at all. They solve entirely different problems.
Oh, not really?
Yeah. Fine-tuning teaches an AI how to behave. If you need a model to output Python code in a very specific proprietary formatting style unique to your company, or say, if you need an agent to negotiate in a specific brand voice, you fine-tune it. You are altering its behavioral patterns.
Yeah.
RAG, on the other hand, dictates what the AI knows. It grounds the model in facts.
Got it. So behavior versus fact.
Yes. And for compliance in high-risk sectors, fine-tuning your data into the model is actually a huge liability.
Why is that?
Because regulations change monthly. If you fine-tune a model on the January tax code and the code changes in February, that model is now obsolete. You cannot spend a month retraining a massive neural network every single time a regulator issues a memo.
Oh, that makes sense. With RAG, you just delete the old PDF from your vector database, drop in the new one, and instantly every agent in your enterprise is operating on the new rules.
Exactly.
Okay, so we have solved the hallucination problem with RAG, and we've solved the audit problem with multi-agent logging. But this leads us to the economics.
The fun part.
Always.
Yeah.
We mentioned dropping the cost to 145 euros per inquiry, but running 3 distinct AI models, having them constantly query databases, summarize documents, and draft responses, inference costs are notoriously high. The computing power required to run all these agents could easily wipe out the savings from the human hours.
Yeah, the underlying cloud costs are really the invisible trap of the AI transition. When enterprises move from a small pilot program to full-scale production, they almost always experience severe sticker shock. And it almost always stems from a lack of model routing, which is also known as model cascading.
Inference costs, for those mapping out budgets right now, are basically the toll you pay every time an AI reads or writes a piece of text. It's measured in tokens. The AetherLink guide details how to stop bleeding money on these tokens. Let's explore that model routing.
So the mistake most companies make is assuming they need a massive state-of-the-art frontier model, the incredibly expensive ones capable of advanced reasoning for every single step of a workflow.
Yeah.
But if Agent 1's only job is to look at an incoming email and categorize it as either billing or technical support, using a top-tier model for that is a profound waste of compute.
Here's where it gets really interesting. It's like hiring a senior $200 an hour software engineer to update the copyright year in your website's footer. Sure, they can do it, but you are just burning money. A junior developer could do it for a fraction of the cost.
That is exactly the dynamic. The guide recommends an escalation architecture. You route your initial basic queries to smaller open-weight models. These models cost fractions of a cent, often $0.001 per API call.
Super cheap.
Very cheap. You write logic into the system that checks the smaller model's confidence score. If the task is too complex and the confidence drops below a set threshold, the system automatically escalates the query to the larger 5-cent model.
Oh, wow.
Implementing this cascading routing saves enterprises 40 to 50% on inference costs immediately.
And the guide outlines several other engineering disciplines to manage costs, too. Caching prior argy retrievals is a massive one.
It's huge.
If your financial firm gets 10 inquiries in an hour asking about the exact same new AML directive, your database shouldn't be running fresh, computationally expensive vector searches every single time.
No, definitely not.
The system should just recognize the duplicate query, pull the cached document retrieval from the first search, and hand it straight to the agent. That alone cuts inference costs by another 25 to 35%.
And we also have to look at the timing of the processing, because not every multi-agent workflow needs to happen in real time.
Batch APIs.
Yes. If you have an agent tasked with auditing the day's transaction logs for compliance anomalies, that doesn't need a sub-second response time at 2:00 p.m.
Right.
You can use batch APIs to submit tens of thousands of queries to the AI provider to be processed overnight when global server demand is low. Because you are allowing the provider to process the data on their schedule, they typically discount the inference costs by 50%.
Okay, so we have our multi-agent team. They are grounded in facts via RE, and we are routing them efficiently to save money. But there is one final architectural hurdle before this system is truly production ready. Integration. How do these agents actually reach into our secure internal databases? We're obviously not hard-coding our core customer database credentials directly into a raw AI model's prompt.
No, doing so would be a catastrophic security failure. This is where the guide introduces a really vital piece of infrastructure, the Model Context Protocol, or MCP. In a complex enterprise environment, your agents need to interact with legacy CRM platforms, citizen databases, and secure financial ledgers. MCP is an open standard that dictates exactly how AI models discover and interact with those external tools and data sources.
I like to think of MCP as the airlock on a spaceship. You have the AI agent in one environment and your highly sensitive regulated database in another. You cannot just open a door between them, or the atmosphere vents into space, meaning your data is exposed.
Exactly.
The MCP server is the pressurized chamber in the middle. The agent knocks on the airlock, says, hey, I need the transaction history for client X. The MCP server checks the agent's permissions, sanitizes the request, reaches into the database, retrieves the specific data, and passes it back through the airlock to the agent. So the AI never actually touches the core database.
That analogy perfectly captures the isolation mechanism. It is compliance by design. The MCP server enforces rate limits, preventing an agent from accidentally triggering a denial of service attack on your own infrastructure.
Yeah.
And it logs every single access attempt for your audit trail. But perhaps the most strategic benefit of standardizing your infrastructure on MCP is vendor neutrality.
Because it acts like a universal adapter. It's basically the USB port for enterprise AI.
Yes, exactly. If you build custom API connections for one specific AI provider, you are locked into their ecosystem. But if you build an MCP server over your internal databases, any AI model that supports the protocol can plug into it.
That's incredibly powerful.
It is. You could use a proprietary model for complex reasoning today and then seamlessly swap it out for a cheaper open source model next year without rewriting any of your internal data integrations. You are future-proofing your architecture against the rapid churn of the AI market.
Well, we have covered an immense amount of ground today. Moving from the monolithic model trap to hierarchical multi-agent structures, unpacking the EUAI Act explainability mandates, curing hallucinations with RGAG vector databases, managing inference costs with model cascading, and securing it all with MCP airlocks.
It's a lot to take in.
It really is. As we distill this into actionable insights for the business leaders listening, if someone is mapping out their 2026 AI roadmap right now, what is the single most critical takeaway? For me, it is the practical, phased implementation approach detailed in the AetherLink guide. You do not build a 50-agent orchestration system on day one.
Oh, absolutely not. It is a guaranteed path to failure.
The roadmap dictates starting Q1 purely with assessment. You audit your data readiness for vectorization, and crucially, you define your acceptable risk thresholds. Like, a retail company generating product descriptions might tolerate a system with 98% accuracy.
Right.
But a Den Haag financial institution handling asset management requires 99.9% accuracy. You build your guardrails to that specific threshold. Then, in Q2, you run a single domain pilot, maybe just customer complaint categorization. You run the multi-agent system in parallel with your legacy human processes to benchmark the accuracy and the real-world token cost. You only move to scaling across the enterprise once that pilot proves it can generate perfect compliance logs.
That disciplined approach is so vital. My primary takeaway from this deep dive is a necessary mindset shift regarding regulation. When the EUAI Act was first proposed, the narrative was driven entirely by anxiety.
Oh yeah, a lot of doom and gloom.
Right. Many enterprises viewed the compliance mandates as these heavy burdens that would stifle innovation and slow down deployment. But what we are observing in hubs like Den Haag is that strict regulatory environments are actually catalyzing better engineering.
The constraints are forcing stronger architecture.
Yes. Proactively building systems that comply with the EUAI Act, implementing robust RAG for factual grounding, utilizing MCP for secure data isolation, generating deterministic audit logs through agent handoffs. All of this forces an enterprise to build highly reliable, incredibly resilient software.
Right.
The companies adopting frameworks like AetherLink's AI-led architecture are not just achieving legal compliance. They are unlocking higher operational efficiency and lower error rates than their competitors who are still trying to move fast and break things. Compliance is no longer a legal headache. It is a profound competitive advantage. You are building systems that you, your customers, and your regulators can actually trust.
And trust really is the ultimate currency in this transition. If you're looking to dive deeper into these architectural frameworks, or if you want to explore the AetherTV case studies and the full 2026 enterprise guide we unpacked today, you should visit AetherLink.ai. It provides the technical blueprints necessary to navigate this shift.
It is essential reading for anyone leading an enterprise deployment right now. I do want to leave you with one final thought to mull over as you design your internal infrastructure. We have spent this time discussing how your multi-agent systems interact with your own data and your own customers. But as this architecture becomes the global standard, we are approaching a horizon where your company's AI agents will inevitably begin interacting directly with the autonomous agents of your vendors, your supply chain, and your partners. When two autonomous agents from different companies negotiate a service contract or agree to a data exchange in milliseconds with zero human intervention in the loop who is legally responsible for that handshake.
Wow. When that microsecond negotiation goes wrong and a breach occurs, who is staring down that 6% global revenue fine, that is the absolute bleeding edge of liability, and it is the exact challenge we will have to solve as we build the infrastructure of 2026.